Welcome to a demonstration of the real-time production and process monitoring functionality from DelmiaWorks. We will outline the way in which a project manager can use the system to take corrective action when necessary, using predictive analytics to ensure orders are getting to their customers on time. Using real-time production monitoring, a project manager can see an overview of work orders that are running across the plant floor. Color coding provides quick reference information as to the status of work order production. Green means the given job will be completed on time, red means it won't, and yellow signifies downtime for the particular work center. Real-time production monitoring determines this by cycle counting all the currently running jobs and comparing these cycles against the information contained in their corresponding bills of material. If a given work order is trending out of spec and production monitoring predicts it will not be completed on time, the system notifies the user. Let's use number 72876 as the example here, which you can see in red. The project manager can then look at process monitoring to see that the cycle times are trending out of control, reaching and eventually exceeding the upper control limit based on the system's performance prediction. In order to diagnose the reason for the increased cycle times, the user can examine the various inputs of process monitoring data: cycle time, maximum fill pressure, and barrel temperature. In this case, we see a direct correlation between the barrel temperature and the predicted out-of-spec cycle time, which tells the engineer this must be the cause for the problematic readings from the system. They can then work to directly address the problem, helping to resolve the issue in subsequent jobs for the particular work center. For the order to be completed on time, the project manager decides to create a new work order to run the balance that remains from the first machine. The new work order number, for this example, will be number 72877. Because the project manager knows the issue with the first work center did not involve the mold itself, they install it to the second work center in order to continue production. As the new job is being set up on the second work center, engineers can further diagnose the root cause of the barrel temperature issues on the first machine to ensure subsequent jobs will run more smoothly. The system uses stored manufacturing data for the particular bill of manufacture to determine the run's best information for project managers, that is, the machine which will run the given job as efficiently and successfully as possible. Each work center is given a performance percentage rating from the system based on past cycles. The project manager then uses these scores to determine which work center should run the given job. In this case, the work order has been running on work center 33, but since engineers are currently working to diagnose barrel temperature problems, the project manager can then schedule the job on the next highest scored work center, in this case, number 5. Doing so assures that the work order will run on a machine that is well suited to handle the particulars of this job. Once the work order has begun running on the new work center, the project manager can continue monitoring the predictive analytics within process monitoring to ensure cycle times are back on track. Production monitoring now shows the order will be completed on time. We have just seen the power that DelmiaWorks' real-time production and process monitoring system can provide project managers in the form of robust predictive analytics. This information helps to prevent problems before they trend out of control, saving manufacturing organizations time and money.